So in this session we will see angle of a friction, coefficient of a friction and cone of a friction. We shall see these three topics in this session. So what is this angle of a friction? The angle of a friction, the angle made by the resultant r dash with the normal is called as a angle of a friction. So now question arises, what is this r dash? I will explain here. Let us take a wooden block placed over a flat surface. This wooden block is having a self weight of W. Because of this self weight, there is a support reaction developed. Okay, this is the support over which the wooden block is placed. Because of this, there is a support reaction developed. I will call it as R. Now what I will do, I want to move this body in a positive x direction, so I will apply a load P or force P on this body. Because of this application of force, due to the roughness of the both surfaces, there is an development of a frictional force in this direction. If I extend the line of this frictional force here, and instead of these two forces, I will draw a resultant R dash. Okay, this is the resultant force R dash developed because of this normal support, this support reaction or normal reaction and the frictional force, and this resultant makes an angle phi with this normal. Okay, this phi with this normal. This angle phi itself is called as angle of friction, and the R dash is nothing but a resultant of a frictional force and the support reaction or normal reaction. The angle of a friction is nothing but the angle made by resultant R dash with the normal is called as angle of friction. Next, coefficient of friction. Let us take a wooden block here and is placed over a surface. The wooden block is having self weight of W, because of which a support reaction R or normal reaction R will develop here. If I apply a force P here, there is a development of a frictional force. Okay, if this frictional force reaches to the maximum is nothing but this itself is a limiting friction, maximum force or limiting friction. Okay, the ratio of this maximum force F max and the support reaction or normal reaction R is nothing but the coefficient of friction, the ratio of maximum friction, or this maximum friction is also called as a limiting friction. The ratio of the maximum friction to the support reaction or normal reaction R is called as a coefficient of friction, and this coefficient of friction is denoted by mu. So one more thing is we need to know is this is a constant value. The coefficient of friction is a constant value. Why? The question arises why? For a given body, because of this surface roughness, the maximum or the limiting friction is a constant value for this given surface and a given body. The weight of the body is given, means the weight is not changing, means this support reaction will not change. For example, the maximum limiting force is 100 kilonewton and the maximum load of this body is 500 kilonewton. So the reaction developed will be equal to 500 kilonewton. So this limiting friction value will not change, and this support reaction will not change. So 100 divided by 500 will give me the value mu. So this mu is a constant for a, I can call for a given system, this mu will remain constant, mu will not change. Okay. Next we shall see cone of friction. Now question arises, what is this cone of friction? Let us take a wooden block again. I will place it over a surface. If I try to move this wooden block in this direction, what happens? Because of this self weight, there is a support reaction developed, and if I try to move this in a right hand side direction, there is a frictional force developed. Because of this frictional force and the support reaction, I can draw a resultant force R dash, which makes an angle phi. Okay, let us take this point as O, and if I try to move this body in the direction in a left direction with the same force P, what happens? Because of this, there is again a frictional force developed in the opposite to the direction of motion. I will extend its line of action here, and if this frictional force and this resultant again makes an resultant of having R dash, and it will make an angle phi here. So I will neatly draw here. This is also R dash, and with to the normal it is making phi, and this is also R dash and making an angle phi with the normal. And if I draw here, it makes a cone, right? These two are making a cone with keeping this O as a vertex. This itself is called as a cone of friction. So because application of same force in right hand side or left hand side, there is an equal development of this R dash having same magnitude and same angle of friction. So it will, if I draw that, that will look like a cone right here, cone with making this O as a vertex. This itself is called as a cone of friction.